Whipple. I'm a digital learning lead for Anglophone West School District, and welcome back to this afternoon's sessions on LEARNEast or for LEARNEast. And we're always excited to have our friends from Brilliant Labs. They are, without a doubt, I wouldn't want to offend any of our other program partners, but you guys have been there with us for such a long time and almost right from the beginning. And so it's great to have such good friends, and they help teachers in so many different ways. This afternoon, we're excited to have another great session from Brilliant Labs from a couple of their brilliant people. So this afternoon, Alicia Collins and Natasha Vautour are going to be here this afternoon to talk about the futures of biomaking. Honestly, I have no idea what this means, but I'm excited to find out. So thank you guys for taking of your time and expertise this afternoon and sharing it. And we're looking forward to this session. And I'm going to just turn it over to you. Oh, just to remind everybody, we are recording the session. So know that. And I'm just going to turn it over to you guys. Have a great afternoon.
Thank you, everybody, for joining us. We are indeed excited to be here with all of you and explore this whole idea of biomaking. A little bit about us. So my name is Alicia Collins. I'm at the Brilliant Labs with the Brilliant Labs Atlantic team as a creative catalyst. I joined last year, like during the pandemic, so I still have to meet a lot of Brilliant Lab folks in person. But as soon as I joined, I started exploring this idea of biomaking. So I lead the Biomaking initiative, and we also have Natasha here.
Yeah, I'm Natasha. For those I've seen this morning, hi again. I'm the co-program director with Jacob Lingley here, my counterpart for New Brunswick. And I also lead a lot of the creative projects and development of materials and resources. And along with Alicia, I'm learning a lot about biomaking, and it has become a large interest in the past year. So yeah, we're going to share what we're doing today. I'll let Alicia start because she's the brains behind all of this operation right now.
I guess the brains are a lot of initiatives that's currently happening in parallel. So before we begin, I just want to share a little bit about like this presentation format. So we're going to do a bit of intro about the current trends, what is biomaking, what is biodesign, and then we are going to share about the biomaking pilot project that Brilliant Lab has been leading and invite you to explore how all the teachers and everybody within your network can be part of this initiative. So before we begin, I just want to ask you, and you can use the chat or feel free to unmute yourself, like when you hear the term biofuture, like what kind of things come to your mind? Yeah, I mean, the separate words, bio and future. Working with living materials, yeah, that's an interesting one. Yeah, indeed.
I always think of
sorry, go ahead.
I always think of how we can make everything for every living creature. So all our materials, all our decisions, but also for all living creatures. You know, when we think about empathy and all the natural elements, so it's everything related to that.
Yeah, that's an interesting take. I mean, this is the idea of living material or living matter, I guess that's coming, and combining that with tech. When we started exploring this idea of biofuture, I guess for us, the term sustainability came first. And every time I look at that, you think about like, of course, there's technology, but when we think about innovative technology, there's a sense of conservation from past as well. And if you look at it, conservation, it's all about securing the best from past. So that's what leads me. Let me see if I can share my screen again. Sorry, I have to keep going back and forth. When we think about this idea, it's like biodesign, although, I mean, people are like exploring it in the modern world, but it's not very novel. It has been there existing in the past when we think about selective breeding, genetic modification, all the things about all kinds of bacteria and viruses and innovation to kind of combat that. It's been happening for a long time. Somehow in the current trend, people are like repackaging this idea as biodesign, which they say it's a field that insists us to explore living matter, as you mentioned, biological materials, to design something for human purposes. And we try to add the word, kind of like make it more personal, as biomaking, where we are exploring this whole idea of biodesign, bioinnovation, biofutures, whatever you call it, to integrate in within the makerspace. And our idea of makerspace is along with the constructionism. So it's like, of course, you design like something new and innovative, but something that is also personal, something that you designed to either solve a problem within your community, to express yourself. And when it comes to biomaking, you are collaborating with millions and billions of bacteria and fungus and kind of yeast and like all these microbes around you to create something meaningful that's relevant in the future and into your present, and make something better. So now it's like they say that everything that's kind of, it's not constructed, but it's like grown. And there are three aspects that we consider when we think about sustainable future with biomaking. A is seeking inspiration from nature. A lot of you are familiar with the term biomimicry, where you're trying to look and observe nature, and not just like patterns and like things that you see, but also different systems, the processes that work, and try to mimic that and try to create something that builds on that. Collaborating with nature is you're trying to make friends with all the microbes and all the living materials around you and try to co-create something meaningful. And when you create something meaningful, it kind of eventually goes back to the nature. It's for the benefit of nature. It's more sustainable. It's something that helps us, that helps our environment, that helps all the community and all the other creatures that live on Earth. And we tried to put together as like these three different concepts. So biomimicry, as I mentioned, when we seek inspiration from nature. And in biomaking, that's the process where all the young people or all the teachers that we work with, they look and observe. There are these like process that we follow, and we create something novel just by observing the mundane that happens in nature. Biocollaboration, which is very interesting, where you try to make friends with the microbes that's around you and design something. And biofabrication is related, where you invent something that's more bioderived. So that's where you and the other species and creatures are coming together to co-design something, new product, something that has never been explored before. And as we are talking about it, a lot of these ideas in biodesign and even like in new entrepreneurship, like these things are still in the making. There's so many companies that are emerging. And in the biofabrication, currently, the lot of systems and organization that exist, they're focusing on these creatures and fabricate, construct something. So we have fabrication tools like 3D printer or laser cutters or vinyl cutter, all kinds of things that you see in the maker culture. But imagine, instead of the materials that you have like wood or acrylic or filament or whatever you use, you actually use these living cells. And there are some examples that we can share, but these are the common things like this bacteria. So we will explore the things with SCOBIA, things that happens that makes kombucha, so this colony of bacteria, things that make yogurt, so you can collaborate with them and create fabric. Algae is another organism that people are really exploring, that's like found so much in abundance, but people are exploring how do we find energy resources around it? How can we make biofuel with algae? How can we make new fabric? How can we make new products? Yeast is another thing that people are exploring to express different genes, to genetically modify and create something else. One of my favorite projects in the modern world is an ice cream company that uses basically yeast to express the same gene that milk expresses. So you have these milk-free ice cream, but that's made from yeast. So many interesting things are happening. Fungi is another thing. Mushrooms, abundant. They're everywhere around. And there are, in the modern world, there are people are exploring new packaging design, new textile fabrics, even building materials with fungi, something that we have never explored before, but the future is heading towards that direction. And when we think about the future that we have not explored, the idea of speculative design come into place. Speculative, as the word expressed, that you're trying to imagine something, speculate something that's not there, What if scenario? What if there's zero waste homes? What if you can make electricity in your backyard? All these scenarios that currently don't exist. What if we engage our young people, our students, to think about a future that's not there, but something that we can head towards? So that's why the idea of speculative design is so important. And these are some examples, like all the things. Imagine if we lived in zero waste homes. Imagine if we have this door-to-door service that takes only worn out clothes and bring them back to an upcycling facility. We don't, I mean, sometimes there are these innovative ideas that exist, but the systems to put them in actions, they don't exist yet. So when we think about biofuture, we don't need to necessarily think only in terms of materials, but we also need to think about process and also the steps that allow us, the services that can put those materials in action. So of course you have, let's say, invented a packaging, a mushroom packaging. How can we make it part of everyday home? How does it come to us? And it's still like a lot of things that needs to be thought about. It's not something that we thought about this idea and it's going to come next tomorrow. We really need to think this through. And that's where most of the disciplines come together. So there are some ideas that we want to just share, which are currently in the making. So when we think about architecture, it's one of the field, actually the earlier field, like a lot of architects started focusing on biodesign and biomaking. So the image you see, there's this Museum of Modern Art in New York. They have this whole building. They collaborated with a company, Ecovative, that makes mushroom-based products. So this whole gigantic building structures, as you see, is made of fungi. And fungi, the way they modified it, it's also the material that's kind of flame retardant. So it's not something that's just like eco-friendly, but also maybe it's better than our current concrete structures. People are also exploring the idea of like modifying the trees and stuffs and like use them as a building structures, not completely harnessing or like harvesting those things, but also just seeing like if something is growing, how do we like look at the natural course of its going and then create. So this is like an interesting bridge that talks about like how things grow naturally, but you're kind of like creating a mold for it. The biobrick and concretes, that's another emerging idea where people are exploring, as I mentioned, the flame retardant bricks, but also self-healing material that can withstand all kind of weather condition and can stay, and also has like interesting porosity, so it can keep the temperature like cool, so you don't even need a thermostat. So people are still exploring these new ideas with the building materials. Energy, that's pretty interesting one, where there's so many companies. So on the right, if you see the bioreactors, that's basically algae based. So these lamp structures, it's made by these designers who have used these like algae fuel. You put it in and they basically breathe. And as they are breathing, they're kind of letting it out like energy. So imagine you have like these algae brewing or bacteria brewing in your basement, and somehow your whole house has electricity. There are multiple other ideas. People are looking at biofuels from, I wouldn't say food waste, but food surplus, something that's there that are either like agricultural surplus or something that is home, but how do you use that? Instead of going it to waste, you create fuel around it. And this is an interesting one. There's a company called Mudwet. And Natasha, maybe you can talk about it because you have this kit.
Yeah, I have this kit. And unfortunately, I just moved back home, so I had to put it away. And this morning I was looking, I couldn't find it. But it is creating energy and making a little, and it's something you can use in your class. And it's making the little LED light turn on using the microbes inside the dirt. So you have to get some nice soil. I had some marsh soil here, so it was really nice and rich, and then after a while the bacteria grow and it creates energy, and you can read how much energy you're using an app on your phone. But yeah, it's pretty interesting to it's pretty cool to have kids light up a little LED light using, they think it's using dirt, but it's really all the chemical reaction of the bacteria inside.
And that's interesting when we think about bacteria, like how abundant they are. So this bacteria that Natasha is talking about, it's Shuvionella, or Shuvi as like the short form of it, that is found in dirt. That's omnipresent. It's everywhere. And that bacteria, it's kind of emits electricity. It has these charged electrons that it lets out. So what we are doing is you're harnessing the power of this bacteria, again, that's found in dirt. So you're feeding it ketchup or soy, whatever you need to let it grow. And in return, the Shubi bacteria is giving you electricity. Maybe it's an LED light for now, but imagine if you can turn the motor. I guess if you combine different batteries, you can have a fan running too, like a tiny fan. And if you have a lot more bioreactor, like a big size, let's say a shed completely full of it, maybe it can power your computer or even your whole house. It's very, very powerful idea. It's a slow design. It's kind of a give and take exchange process. You need to, it's like bacteria are your pets, basically. You're giving it food, you're creating in them like in a proper condition, and in return, they're doing the work for you. So that's where it's bio collaboration. Everybody is kind of exchanging something, some resources around. So that's one idea that people are exploring in energy aspect. Fashion, this is my favorite. I have background in fashion design, so I kind of focus a lot more on this. But there are actually companies like Algae, Bolt Thread, MycoWorks that are using leather, which are made from mushrooms, as an alternative to like a traditional leather making process. Algae uses, again, algae to make these biodegradable wear, that's shoes. And then people are also exploring, as I mentioned, the idea of food surplus. So like corn husk, mushrooms as one of the things, but also like all kind of peels and the fruit peels that you have. So people are really looking into making fashion out of it. And it's not kind of like just like a ramp fashion that you just use it once, but basically you can really modify it with gelatin algae that you can actually wear it so it's durable, but then yet it's biodegradable. So people are exploring. You can look into this. 3 of my favorite companies like Amado Leather, the Bolt Threads is another one. Bolt Threads did something very, very interesting. So as you know, this silk it's a whole process about, you have silkworm, you collaborate with them, and basically you get the silk. But they tried to explore the spider silk, and spider creates these threads which are very, very, very strong. But it takes a lot of effort to get the spiders to do that. So they have figured out a technique to actually have the yeast that you brew, like just a regular yeast, to express a gene that makes these thread. So you can make the spider silk, not from the spider, but from the yeast. So yeah, you can Google all about these companies. They're actually there. They actually exist. I think even the designer Stella McCartney is collaborating to create with Bolt Threads to create these sports line. And more idea, I think it's coming. There's so many companies that are emerging in and exploring biodesign and biomaking. So we are almost there. Even products that people are exploring, something that we have never seen before, something that has never existed. So here's an example of fungal headphones. Now, everything that you see here, except the electronics, is designed with the mushrooms. So like you can see it here, the brown thing, it's like mushroom leather. The other thing is acoustic sound absorbing material that's made from mycelium, which is the root of the mushroom. And there you have the headphones. There's another company that's actually making biodegradable circuit boards. So that's they just started actually less than a year ago. So maybe we have like future laptop made out of biomaterial. Shellworks is a project they're using chitin. Chitin is found in mushrooms primarily, but also in like shells of all the sea animals, like so lobster shells, shrimp shells. They have like an essential component, chitin, which is a great alternative to plastic. So people are exploring biodegradable materials. And as I mentioned, the Adidas has collaborated with Bolt Threads. So this is the example of a shoe made with the spider silk, which is indeed made with the yeast. So people are exploring these new designs, and who knows, one of our students may start a company or come up with a completely novel material. But you need to start somewhere, right? You need to start these small process, like these low ceiling process that inspire you to create all these advanced ideas. Food is another industry. So lab grown meat. So there's this organization called New Harvest. And I think it started in 2015. And 2015 was the first time when they made beef in a petri dish. So the food was made like lab-grown meat. It was like some $200,000 meat just in a petri dish. But now, currently, like we have so many companies and it's like Impossible Meat Burgers, Memphis Meat, they're exploring this idea of lab-grown meat. In fact, the latest Canadian company I just read just 2 days ago, they make pet treats like dog food and cat food from like lab-grown meat structure. So people are looking at more sustainable ways to have nutrient-rich foods to solve this whole like hunger problem. Of course, biodegradable food packaging is another area where people are exploring. So as you can see, this is an artistic project where you're looking at a gelatin and algae-based bioplastic, a bottle, but you can also see how the bottle is degrading. So if you go from right to left, you can see the stages of degradation, what happens slowly. Edible water bottle, that's another project that's been there. So there are some of these things that we can start small, but also in the entrepreneurial world, in the product design world, people have actually explored these things. So as I mentioned, the cow-free milk products, the dairy ice cream without the milk, that's a very interesting one. Just started in LA 2 years back, I think. And that's it. So where do we start? How can we make this happen? So Brilliant Lab started this pilot project, which Natasha can talk more about, to get you all excited about how you can start all these biofuturistic idea in your school, with your students, in your classroom, or virtually.
Yeah, so we started last year really exploring biomaking with students in the classes, and we had the pilot project, which came with 4 different activities. And one of the first ones was creating a mushroom paper, so mushroom-based paper. So this one here, I made a cardboard, so it's really thick, and it's made out with mushrooms, and it's really getting students thinking outside the box. So what's the difference between using mushrooms to create paper than using trees? Kids love the idea of thinking about nature, and we know trees, they take a long time to grow, whereas mushrooms, you wake up in the morning and there was none there the night before, and now your lawn is full. So they grow really, really fast. So they're very sustainable in that part. So how can we use mushrooms to make paper? So that's a fun activity to do with students and get them thinking with this one. The picture in the middle is actually a pair of earrings made out of SCOBY and kombucha. So they grew the SCOBY, and then after it's grown so big, you let it dry. And I have a sheet here. This one is really thin because it almost feels like a silk paper, because I wanted to create a brooch out of it, and I just never got time to do it. But this one took me about 2 weeks to grow. So when you grow it, you have it. I'll just show you in a second. I'm going to get my display thing here. So when you grow it, it's here growing in my office. I have some here. So this one is pretty big. It's pretty much due to get it to dry, and it's pretty slimy. And it is like, if you lift it, it is it's dripping. So it all grew, and this one is ready to put to dry, and it's a little bit vinegary. So in a classroom, it can get a lot. It's nice to have them in a very well ventilated area, but then it takes like maybe 2-3 weeks. You can grow and have it dry up, and then make something. Have students make out of it. We've seen some students that made little lamps, so they put LEDs in them, and it was pretty cool. We had some students who braided them and made bracelets out of them. So it's really exploring different materials. So how would it be if all of our clothes were made of materials that came from grown with bacteria? And get students thinking also about the environmental aspects of fast fashion and all those, how it affects us. One of the activities was making a conductive bioplastic with an algae base. So Alicia, don't hesitate to stop me if I say something wrong. So bioplastic. So imagine if all of our technologies were created with a plastic that was degradable, or a bioplastic, instead of having all these plastics that are all our telephones made, and they last 2 years and they become a big polluter, because we all know that technologies are not made to last long, same as our appliances. What happens? How could we make it that those appliances are more sustainable in that way? So how can we use those bioplastics for that? And the third picture that you have here, it's inside, it's exploring microphotography, but exploring microphotography. And what I love about this one is taking it and using materials that are very inexpensive. So this microphotography was actually done with a Foldoscope, which is a $3 microscope. It costs $3.50 for those microscopes. So they're very powerful for a $3.50 microscope, but it's also getting students to think about how can these materials help for the future. They made a centrifuge that costs 10 cents to make. Well, why do we need to make 10-cent centrifuge that you can put in your pocket? Because there are some, there's a Foldoscope. Thank you, Alicia. The centrifuge is because there are countries that have no access to electricity or those big machines to really develop those scientific materials. So having that centrifuge for 10 cents is very accessible, and it didn't need electricity, and it was just a string, cardboard, and a little fiole, a little piece of, a little container, plastic container, and some tape. But it's getting kids to think about, not everywhere in the world still has, doesn't, like there's still a lot of places that don't have access to electricity. So that was another fun one. So exploring the low cost technical materials to explore biology, the growing bio leather with SCOBY and kombucha, which you see the earrings. The other activity that we had was the mushroom paper. And the last one is the bioplastics. So this year we will still be offering those 4 sessions. The pilot, we had created all the resources. Well, Alicia had created a lot of the resources, a PDF, the sheets to really help you and get you going on the activities. But the fun part is really making it and having students seeing their materials grow, and then you make something out of it. So you just explore those materials, and it's getting those ideas inside our students' heads. So imagine if you learn about this when you're in grade 4 or 5, and even in kindergarten, that you can grow your own material and make doll clothes, or make, you know, different things with it. So it's getting them open-minded and thinking about that already, so that later on it can explore and develop more ideas. The first image here is also with all the ink. I'm assuming that's the amino ink. Alicia?
So, yeah, so there's different aspects. So in Bio Ink is a module where you have, I would say, 3 different layers. So the first one, is somebody asked, is hard to gather materials and supplies? The answer is no. And yes, too. So the pilot project, which we started with something that's very accessible. So SCOBY, the layer that Natasha mentioned, it's like the drink, the kombucha drink that you can get it in any grocery store or even farmer's market. And it's like part of the many cultures. Like I'm from India, and we do a lot of fermented food. So it's not something totally novel. Speaking of bio ink, so the easiest accessible idea is like things with anthocyanin. So that's come in like red cabbage or all the berries that basically responds to the pH. So we have this kind of eco-friendly t-shirt activity where people use the red cabbage, extracted the ink from it, and then dyed the fabric with it. And then when you wash the fabric, it can tell you about the water source, like what is it, pure water? Is it like, you know, it has something else? Because each time there's some kind of impurity, the pH would respond and the ink would change. So that's one aspect of it. Similarly, you can have other materials like from food surplus, as you mentioned, all the onion peels and carrot peels and things that you have around. You extract ink from those, and then you dye different things. There's another level to it. That's when the biomaking gets a little bit complex, but not too complex. So Brilliant Lab, we are experimenting with the Amino Bio Kit, which is basically kind of, how do I say this, like a bioreactor and biomanufacturing device, just like a 3D printer, but think about it as like a bio-base that allows your cells to grow. So you get these, as I call it, like not like, because microbes are harmful as well as not harmful. So within the scope of biomaking, we are only exploring things, the bacteria and the fungi that you can get easily around you, but also it's not too harmful. So there's like different levels of these things. So in that, you kind of imagine you take the bacteria, you're trying to modify it, and you're letting it express the ink that glows in dark, ink that responds to the pH. And then you have a t-shirt out of bacteria. So there are multiple levels So as Natasha mentioned, the pilot project, we tested 4 different activities just to see this idea, because biomaking or biodesign, I mean, of course, you saw all these ideas. It's there in the world. It's novel, yet is more accessible. But where is it not accessible? Is in the education world, in schools. Like a lot of teachers, I mean, you don't have to ask this question, like, how can we get this? I think it should be given. We have biological curriculum, we have geometry curriculum, we have all these interdisciplinary design ideas that biomaking can weave into. So that's what the experiment we did it. And I think we're offering it this year as well with those 4 activities.
Yeah.
And there's extended array of activities. So if I go back to the presentation, and so Natasha mentioned there's 4 activities that we did, but this is kind of an overview of all the resources that we have created, different sessions. And when I say resources, that includes a downloadable PDF, a guide for all the teachers with suggestions of how they can combine it with different curriculum. Like if you're a mathematics teacher, if you're an English teacher, what kind of ideas blend into these things in pretty easier way. So here are some overview of different sessions. So the first session, we often starts with biomaterial. So what are some different materials that, so this idea of like collaborating with microbes. So this is an example, as Natasha mentioned, people made lamps with the kombucha leather. So what SCOBY layer she showed you, this is the dried forms, and then there's a light inside. And this is a biodegradable lampshade. And it's pretty stiff, like if you look at it, and it's pretty moldable too. And this is another example. I guess, Natasha, you can talk about the paper with the mushroom that you had.
Yeah. So this one is really how to make mushroom-based materials, and also using, I was also growing some mycelium with it. So this one is just paper with mushrooms and then a little bit of recycled paper. And then you can make 3D shapes. I had a heart and I broke it for some reason. And you can make molds out of it. So it's really rigid. And this is really like a thick cardboard. You can make it really thin. All you need is a little screen. I find these work really well to make your paper and dry it. And they don't take long to make. Like this, making mushroom paper is a blender, a little bit of mushroom recycled paper and water, put it in, and then you let it dry. It's just the exploration and getting students thinking about why we have to explore other ways to make paper instead of trees. And you can also grow mycelium. So the micromaterials, I know Alicia shared a little bit earlier about the micro bricks, but mycelium is very easy to grow. And mycelium is grows, I have some growing downstairs in the pantry still. I just took some cardboard, little pieces of mushroom, rolled it up, sprayed it with water, and closed it in a Ziploc, and it's growing. And we've been experimenting how to grow it in different shapes. So I'm trying to grow it in a mold that'll be a flower pot. And I had a really nice one growing, but my colleague, I had left it to my colleague in Fredericton, and he forgot to look at it, but it grew. So it could have been a nice bowl. So I'm regrowing some more now, and it's really to explore these materials. So once it's grown, you can just cook it a little bit, and it lasts. And they say it's really hard. It's harder and more lasting than cement because it becomes very durable. And one of the fun things about the mycelium that I like to discuss with students is that's how they're actually looking at growing a moon-based living quarters for humans. So instead, they want to build a habitat on the moon for humans with the new halo coming up in the next few years. And one of the materials they're exploring is actually mycelium, which is something that you can grow with simple materials in your home and really explore it with students. And it's getting them to think like, look, they might grow like a whole building on the moon using these materials. And it does sound like far-fetched. And they look, I know my parents always say, okay, you're too much. But no, but it does sound far-fetched in sci-fi, but that's happening right now. So it's just getting students to explore those materials at this moment. So I really like exploring these. And when you play with different mushrooms for this one, depending on which mushrooms, it gives you different papers, different colors of papers, different thickness and different consistency. So it's a lot of fun to explore.
Yeah, and one of the things that, so Natasha and I, we both don't have a pure bio background per se. So initially when we thought of these ideas, I mean, it seemed kind of far-fetched too, but once we started doing it, like I didn't know how easy it was to grow your own mycelium brick. Just with cardboards, you take mushrooms here. But these processes, again, there's so limited resources. So this is our effort to bring together in such an accessible way that teachers don't have to think about like going everywhere. But teachers can focus on exploring their own creativity and experiment more with within these materials. So if you started making mushroom paper, how can we kind of mold them into and make containers out of mushroom? How can you take the mushrooms of different color and extract ink from it? So you can slowly discover how you start with something. Maybe there's an artist who designed like a 3D printed chair, just putting inside like mushroom slurry in a 3D printer, like extrusion process. And these things, again, like the artists have started exploring biomaking or biodesign. And now I think it's our turn. It's our teachers and students' turn to explore it, and not explore it like some reason, but explore in parallel with what's happening in the modern world. Stay up to date. And we start with low ceiling, something that's easy enough, that gives instant gratification, but something that you can keep exploring and go beyond. And Natasha already mentioned about bioplastics. So we are looking at plant-based as well as animal-based. So gelatin is like animal-based bioplastic we've explored, but also using algae and other kind of materials, chitin-based bioplastic. Chitin is, again, like it's tricky. It's like plant/animals too. It's found in both materials, but we're exploring these ideas that you can do it at home. And some of these things are very simple that you can get at the grocery store. Plant-based things are used to make Asian dessert, like China grass, as you call it. In India, we have so many desserts that uses those materials, which are more plant-based and not animal-based. But you can make bags out of it. You just have to know how to mold the right materials, combine it with interesting things like glycerin, so that kind of changes properties of it. And bioplastic is, again, a broad term. You have things that biodegrade, but you also have things that are bioderived, which doesn't necessarily degrade on its own. Like, it's not like you leave it outside and it degrades. And there's one variety of bioplastic that explores that, but there's also things that you use the materials that comes from natural process, but you kind of process it to extend the shelf. So it's like a broader term. But for this activity, we were primarily focusing on something that's more compostable and not just bioderived, but also biodegradable. That's why we use things that's often used in foods. Conductive biomaterial, that's another explore where we are looking at. So this is a circuit that you see made with bioplastic, but we added conductive element. And this module helps explore hydrogels. And you can see like the LEDs light up. So this is conducting. It's kind of like a switch. And biotextile, I guess that's Natasha's favorite. You mentioned in the morning too.
It is my favorite because it's such a reaction when kids are not expecting it when you first do it. So this happens with the reaction of the materials, because when you pour, it's almost like if you pour icing on water, but it's not water, the liquid, and then you pour icing in it and it has a chemical reaction. And it does seem there's a lot of science behind all of these, and some of these experiments are easier than others. Whereas this biotextile, you really have to follow the direction. So like a student can, okay, mushroom paper, you can play a little bit more. You won't necessarily have a reaction, but even if there are natural materials, there's still different reactions. And I remember making a biotextile activity here, and we kind of messed up the 2 steps, and it got warm. So the material that we had inside. So it's very important that even if they are natural materials, they can still have these reactions.
Yeah, and it's very interesting. So this algae knit company that I mentioned about, they use algae. So this was an attempt, and actually it started with the Tech Museum in California, and we're kind of seeking inspiration from them. But this whole idea is like, there's an actual fabric company that uses the same method, and you can actually start exploring that with simple materials. But not just biotextiles, also this activity uses that extrusion method. But it also explores this concept of spherification, which is used a lot in modernistic cuisine, in food. So of course you're making textiles, but some of the scientific elements can be linked with that spherification process. So that gets very interesting and very touchy-feely activity too. My favorite part was, as you can see on the thing, like crocheting with the thread that you make yourself.
Mhm.
And Natasha already showed you about the microphotography so we're thinking about this idea of like how you make your own tools. We love Prakash Labs at Stanford, and they make these devices like foldoscope, like dollar microscope. But it's amazing. So the whole idea is not necessarily just to assemble and make your own microscope. That's a start. But how do you start seeing things around you? So my favorite part was about just making different slides, capturing it, taking the pond water and seeing what's inside. It's kind of like you have a tool, A, that you made yourself, B, but you're also exploring. I even use things like nail polish and things. And if you like look at those things, you see such amazing things just within. It's just the power that the tool gives you. Biodyes is an activity where we use the red cabbage ink or kind of food surplus. And now we are exploring this idea of how do you modify a bacteria to express a specific color. Biomimicry is another process which we mentioned in the beginning. You seek inspiration from nature and you make something. And here we are exploring these specific patterns in nature, so spirals, fractals, all kinds of shapes, and then creating a lamp with specific materials. This bio-art, where we are looking at how you can grow art in a petri dish. And there's two elements to it. We've tried that in one of our after-school program. One is like you get a kit that you can get these harmless microbes, and you have this Amino Bio kit, engineering kit that you explore, but also with the yeast that you have at your home that you use in baking, the baker's yeast. So you've done some activity, you use the yeast to make art and let it grow. And somehow you see the bacteria and things more visible. So you're growing colonies. On the left that you see, it's basically silkworm. So this is a lamp. You see like the live silkworm. So you create a structure for them. And silkworms like basically wood and paper, all natural materials. But in this one, as you can see, you're kind of collaborating. You've created a structure and they are weaving things for you. So instead of like, generally silkworms basically have cocoon, they spin around themselves, but if you put them on a flat surface, they can weave flat. So instead of a process where you have a cocoon, you kill the silkworm and you take the silk thread out and then you make it, you're kind of reversing the process. You just place the silkworm directly on a mold and then they do the work for you. And you're not killing them. They're still alive, but you're kind of giving them a frame, you're giving them food, you're giving them a place to go. And of course, you're controlling the temperature so that they are not basically, they don't need the cocoon to like stay warm and stuff. So you basically creating an incubator for them and they are helping you create the structure. Tinkering with proteins, so we're also exploring these ideas that not necessarily lead you to make something tangible in the end, but something that lets you explore the idea. So tinkering with proteins is another example where we have just used eggs to explore this idea of like, what are proteins, how they express different things, how you kind of deconstruct and denaturize proteins to change the behaviors. And some of these practices we use a lot in baking and cooking and other stuff. But this is just an interesting way to kind of zoom in to those elements. I think Natasha mentioned about the centrifuge. So DIY lab tools is another module where we are looking at how you can make your own tools and something that's based out of a toy. And all these things, centrifuge, if you look at it, it's like $1,000 and things you explore in the lab. But this is when you just use cardboard and some tubes and you do the process yourself. And it's very playful. So these are the different activities we have compiled. There are a few more, but if we start talking about it, I guess a 1 hour session is definitely not enough for that. And there's more coming. We are definitely exploring, Natasha and I, we were just talking about we're trying to create this model of Talk to My T-shirt. So basically a T-shirt that has all these bio elements. So you make the fabric, but you also make the ink from bacteria, and you kind of have this whole setting. And Natsai Audrey, she's a UK-based designer. She's the first one who's created these scarves that you put like bacteria have this specific pattern. So each scarf has a unique pattern because it's the microbes that are doing the work, and they are kind of creatures. They have their own behaviors. It's kind of like raising a baby. You can create an ideal environment, but baby make their own decisions. And you never know, you might get an unexpected result, but you can still like create a conditions around it. And that's where we are at. We have started compiled these 12 or 13 activities that are, we call it like low floor, so like easier for all the teachers to start. But it's our hope to also raise the ceiling, to explore a little bit more advanced structure in a non-threatening way, so that people who are not content matter experts can still feel relatable and still explore multiple ideas with these modules.
And it's also, we don't have all the answers, but we're just starting to explore and getting it in students' hands and teachers' hands and getting them thinking, and also developing more sustainable projects for the schools. But less, when you think of all of our projects that we throw out at the end of the school year, well, if your projects decompose or they're with biomaterials, it's not as harmful. It's very interesting. And see, this is the darker color of the SCOBY here that made a knot. So I'm looking at making different things with all these materials. I don't know if there's any questions. I know I've got some people on the chat wanting to learn more about these. So I have 3 names on my list: Peggy, Crystal, and Jan. And I kept your emails here. So if there's anything, don't hesitate to ask more questions before we go, and or send us an email at Alicia or I.
Put our slide with our email back on.
Okay. And you can always subscribe for our mailing list to receive our newsletters that come once a month. And this is where we will send the information to register for these activities. So I just put it there. If you haven't subscribed yet to our newsletter, don't hesitate to subscribe to that.
And we think, I mean, although we are working on creating these resources, but it's literally kind of a co-designing process. We are looking forward to explore more from teachers. Like, what are certain things that you are excited about? How can we bring new content to you that relates to your specific content that you're exploring, some ideas that you're exploring? A couple of things that's coming. I have one example. So we are looking at, you see these beads. So just like those water beads that you can find easily, we're trying to see how you can make shape changing or morphable structures using those, kind of like an underwater exploration. That's one of the module that's coming up. Another module is looking at something in your kitchen like food surplus, and how do you make products from that. So imagine you're creating new cutlery and bowls and silverware, not like with food. So that's another thing that we are exploring. If you don't know, B-board is our own house, like a microcontroller. We are trying to see how you can make inflatable structures with bioplastic using the B-board. So all these ideas that's kind of coming up, they are in the making, but we're always curious about what people are curious about, what they're excited about. So if you have some ideas and would like to learn more about a specific thing, don't hesitate to write to us, and feel free to reach out.
Well, perfect. Natasha and Alicia, thank you so much for spending some time with us today. I'm my head's just going like trying to figure out all of this stuff, and I know there are teachers. Well, you see the response you're getting from the teachers here, and they're pretty excited about what you've shared and some of the ideas. And I think you've generated a little bit of business for yourself, and I'm sure they'll spread the word, and you'll be in a lot of classrooms this year. And we love Brilliant Labs. We love the kinds of things you do, and thank you so much for spending time and sharing with us.
Thank you for having us.
Okay, so just a reminder to fill out the the form to win great prizes at the end of the day, some of them from Brilliant Labs. And so thank you to Jacob and the rest of the gang there. And so fill that out on the way out. And if you guys have any questions, you guys know how to contact Natasha and Alicia. And I got to go find my Twitter feed and then follow a couple of new people I see. Thanks, guys.
All right. Thank you very much.